Welcome to my channel. For some of you who are new here, I'm recording a video sequence on integration, and the link to a playlist which contains all of the videos on this topic is in the description down below. Today we are dealing with the following integral. It's arctangent x dx. We'll use integration by parts here, but in the first place let's observe that there is a hidden 1 in this expression, right? It's arctangent x multiplied by 1 multiplied by dx. It's a very common trick when we are stuck, and let's see how can we use integration by parts here. Now that we have two functions, namely arctangent of x and 1, we can proceed with integration by parts. Not that hard it is to observe that we should choose 1 as g prime and arctangent of x as f. In the background, our thoughts are as follows. We think, okay, we have two functions, arctangent of x and 1. Well, it's not that easy to compute the integral of arctangent, while having 1 as derivative of some function is pretty straightforward to compute. It's x. So that's why we end up choosing arctangent as f and 1 as g prime. I hope everything was clear up to this point. So let's proceed. Now remember that in integration by parts we want to obtain the following form: fg minus g f prime. So let's proceed down here. First we just rewrite the arctangent of x as our function f and multiply this by antiderivative of 1, which is x, minus. Now that we have g in our hands, which is x, we just rewrite it and multiply this by the derivative of f, the derivative of arctangent of x, which is, remember, it's 1 over 1 plus x squared and dx. Let's move it above a little. Right. What we have in our hands is we have x times arctangent of x minus x dx over 1 plus x squared. I hope there is no problem in transition from this to this, which is indeed equal to x times arctangent of x minus. Now let me write directly the answer of this integral, and while I'm doing so, you think on how should we evaluate it, and once you see my answer, just think why it's right. It'll be 1 over 2 ln of 1 without absolute value square and plus some constant c. And this is our final answer. Okay. Of course, I won't stop here. I'll explain now how I calculated the integral of x over 1 over plus x squared. I hope you took your time and thought of this for some time. Let me show you this. First, I'll tell what was in my mind while integrating this, and then I'll do it in a rigorous way. Now, what was happening in my mind is I saw that we have x dx 1 over 1 plus x squared. I said, okay, we have the structure of 1 over some function. Probably the ln is involved. And once I saw that in denominator there is x, which is indeed the derivative of 1 plus x squared, then my assumption is probably correct. So I just thought of the function ln 1 plus x squared. I found its derivative, which will be 1 over 1 plus x squared multiplied by 2x in my mind. And it's equal to 2 times x over 1 plus x squared. Now it means that if we have function ln 1 plus x squared, its derivative will be 2 times x over 1 plus x squared, which is 2 times our integrand. So the function we should choose, it's 1 over 2 ln. And again, why I was hesitating about absolute values is because we need to have absolute values inside, but Then I realized that, okay, we have x squared, which is already positive, so no need for extra modulus. And then I added c. Well, this is what was happening in my mind. Luckily, we had the following structure, so I could do this in my head. Now let me show you the standard way of solving such integral. We have x dx over 1 plus x squared. We'll use substitution here, and the very basic one is u is equal to 1 plus x squared. Then it means that du is equal to 2x dx, right? Now from here our integral is equal to 1 over u, which is 1 over 1 plus x squared, multiplied by du over 2. It's basically x dx. Let me write this in the following form. I think now it's clear. Let's proceed. It's 1 over 2 integral of du over u, which is 1 over 2 ln u plus some constant c. Now we can go back to our substitution and write it as 1 plus x squared plus some constant c. And we are done. Let's leave it as a remark here. Right, so we are done. If you have any questions, feel free to write them in the comment section below, and see you on the next videos.